The next thing that we are going to move on to is Unit 4E, and that is going to be unit rates. So our objective or our goals for this is going to be, we'll know what a unit rate is. So first off, what is a unit rate and how we can create a unit rate. And then you're also going to learn, not in this video, but through practicing problems, how we can use unit rates to solve word problems. All right, so this video should be very quick. So let's get started. All right, so what is a unit rate? Well, a unit rate compares a quantity to one unit of another quantity. So what that means is when we are creating a ratio, that number in our denominator will always be a 1. So no matter what our denominator is or numerator is, a number on the top, we're going to be comparing it to one unit of another quantity, meaning that our denominator will always be rewritten as 1. And a lot of times when you see this, you won't even see it written as a fraction, but what you'll see is it written as like 30 kilometers per hour. Even though this isn't written as a fraction, it's 30, we're comparing kilometers to hours, so we're saying 30 kilometers over 1 hour. But a lot of times when we write this, we will just write it as 30 kilometers per hour, or we will write it as 30 kilometers over hours. And that is still comparing it to 1 unit. For every kilometer, for every hour, we're traveling 30 kilometers. All right, so we're comparing our ratio to where one of our numbers, our denominator, is going to be a 1. And equivalent unit rates or equivalent rates have the same unit rate, meaning that if it's 30 kilometers per hour, well, something that's equivalent to it will also be 30 kilometers per hour. So it will have the exact same ratio or unit rate that we have. All right. A lot of the times, though, that you'll see this, as I was saying down here, is you will see it written as per hour, like it is here, or you'll see it written like a fraction where your units are written as kilometers over hours, and that's representing that we have 30 for that one. All right. So if I give you that we travel 80 kilometers in 2 hours, and I ask you to rewrite this as a unit rate, well, we can then write it as 80 over 2, and what we need to do is we need to then change this to where it's being written as a 1. So we will simply just write 80 divided by 2, and we'll solve for it, which is 40. So we can then say 40 kilometers per hour. So you see, I didn't have to write it as 40 over 1 because I'm giving my units here of kilometers over hours. All right, I'm going to pause this video and erase this, and we're going to do a couple more. All right, so here's another one that we might be asked to do. 25 kilometers in 2 hours. So if we're asked to write it as a unit rate, well, we'll write it as 25 over 2, and it's kilometers over hours. But because we're writing it as a unit rate, we can't compare it to 2. We would have to compare where one of our units is a 1. So that means we would actually do 25 divided by 2 here. And 25 divided by 2 is 12.5. So we would write this answer as 12.5 kilometers per hour. So you see, we're not writing this decimal 12.5 over 1. That's not how we would write this. What we would just write is 12.5, and then we're showing our units as our ratio of kilometers over hour. We're letting the reader know this is what we're comparing here, 12.5 kilometers for every 1 hour. Right? So when we're writing it as a unit rate, it must be compared to 1. If I just say write a ratio, then you do not write it like this. If I just say write a ratio, then we would just say here of 25 over 2. So you have to understand the difference between a ratio and a rate is that our rates are always being compared to 1, whereas our ratios, we're writing them as a fraction. All right, so let's go ahead and talk about a couple other problems before we move on to you solving one and then going into our work. All right, so for this problem, it says a certain shampoo is available in 2 sizes. 15.2 ounce bottle, a 15.2 ounce bottle costs $4.75. Any 34 ounce bottle costs $12.50. Find the unit price for each size, then state which size is the better buy based on unit price. So in order for us to determine which shampoo we would buy or which shampoo is actually a better buy, we would need to compare it as a unit ratio, and that's so that way we're comparing it to the same thing. By us comparing both of these values to 1 as our denominator, whichever one is greater, then be the better buy. So that is going to allow for us to determine which one we should actually pay, because we might think just because this has more, okay, let's buy this one. but in actuality, we're paying more per ounce for this bottle. It may be. All right, so that's something we got to figure out. So it doesn't really matter which way you're going to make these ratios. You can do it any way. I'm going to just do ounce per dollar. You could do dollar per ounce. It's usually how you can see it at times, but really it doesn't matter. So I'm going to create my unit ratio. The first one is 15.2 over top of 4.75. All right, so now remember, if I want to rewrite this as a unit ratio, then this number needs to be changed to 1. So what I'm essentially doing is I'm going to divide 15.2 divided by 4.75. So then I'm going to write this out, and we're going to go through this one together. So 15.2 divided by 4.75. All right, so remember, when we're dividing, we're going to change this number into a whole number. So I'm going to rewrite it so it doesn't have any decimals. I moved this twice, so I need to move this one twice as well, and I add the 0 here. Now, you should know how to divide these because you should have done this in the past. This isn't new. All right, so then we look and see, well, 475, does it go into 1? No. Does it go into 15? No. Does it go into 2? No. Does it go into 1,520? And yes, it goes into it 3 times. So then we will do 3 times 475, which this will then give me 225 plus 1,200, so it'll be 1,425. We will then subtract. So then when we subtract this, we will borrow the 1 from the 2. That will give us 10. So we subtract, that gives me 5. So we have 1 here. We'll borrow 1 from the 5, so 10 from the 5. So 11 minus 2 will give me 9. And 4 minus 4 is 0, so that means it is just 95. All right, now if I'm going to try and go any further, well, I need to add a decimal here because I don't have any numbers to bring down. So that means I'll add my decimal here. So then it's 950. Well, how many times is 475 going to 950? It goes into it 2 times. And it goes into it evenly too. So this will then be minus 950, so we have a remainder of 0. So that means I would rewrite this as 3.2, and I will say ounce per dollar, or you can write it as 3.2 ounce over dollar. All right, so that means for every 3.2 ounces of this shampoo, we're paying $1. So every dollar is giving us 3.2 ounces. So now we'll look at the other one. We have a 34-ounce bottle, and we're paying $12.50 for this one. So same thing. In order for us to write it as a unit ratio, we are going to divide 34 by 12.5, so that way we can get our fraction to be 1. So now if I divide 34 into 12.5, well, the first thing I would need to do is get rid of this decimal. So I'm going to move it 2 decimal places over. What I do to the one, I have to do to the other. So it means this number is going to be rewritten as 3,400. So now I'm dividing 3,400 by 1,250. All right, we can manipulate this a little more as well since they both end in zeros, but I'm just going to go ahead and do this. So 1,254 doesn't go into 3, doesn't go into 34, doesn't go into 340, but it does go into 3,400. It goes into it 2 times. And that will then be multiplied to give me 2,500. I will subtract this. This then will give me 900. Well, it doesn't go into 900, so I need to add my decimal. So I add my decimal there, and I'll bring my 0 down. And 1,250 goes into 9,000 7 times. So then we'll have a remainder of 0. All right, so that means this will have a unit rate of 2.7 ounces per dollar. So since this is greater, this means that this is a better buy because every dollar is giving me 3.2 ounces, whereas this one, every dollar is only giving me 2.7. So I'm getting more bang for my buck if I were to buy this one. Yes, we might have to buy 2 bottles, or we might have to buy our bottle quicker because we're going to run out of it faster, but we're actually being smarter with our money by buying this one because we're getting a better deal, right? So rewriting it as a rate, a unit rate, is just simply rewriting it to a fraction of 1 as our denominator. But as you see, we don't have to write it as a fraction, but what we will write as a fraction is our actual units, all right? Because we won't write 3.2 over 1. This is actually a complex fraction, so we don't really write it like that. So we will just write 3.2, and then we will put whatever our units are in as a fraction or per dollar. This is actually telling us that that is a fraction as well. All right, so there's just one other thing that we're going to discuss, and that'll be it for this video. All right, so then the last question we're going to do in this video is you're riding in a car that is going 40 kilometers per hour. How long would it take for you to drive 20 kilometers? Now, even if these numbers were decimals, let's just say it was 40.5 and 20.5, you can still do what I'm about to do now. We don't like writing decimals as fractions, but when we're solving these problems, we can set them up as proportions. And since we're going to be getting them out of fractions anyway when we're solving by cross multiplying, it's okay to have decimals in there when you're setting it up. All right, remember, we always have to create our equations. So I look at this, and I'm riding in a car that's going 40 kilometers per hour. Well, the first thing I need to do is I need to actually write this as a ratio. So remember, it's kilometers over hours, so I'm going 40 kilometers for every 1 hour, so I'm creating my ratio. And like I said, even if it was a decimal, you could write 40.5 in there. And now I need to look. It says, how long would it take for you to drive 20 kilometers? So that means they're giving me how long I'm traveling. So they're giving me my kilometers. Remember, this is kilometers over hours. So they're giving me how far I'm traveling, which is my kilometers. So that means it's going to be 20. And they're asking how long will it take. So that means I don't know my time. So that means I'm going to put t in my denominator because that will be my hour. That's my time. That's what I don't know. All right, remember, it's all about being consistent. Since it went kilometers over hours here, it must go kilometers over hours here as well. And they told us we drove 20 kilometers. So now we will throw our x up and we'll cross multiply. So we get 40 times t is equal to 1 times 20. Well, 40 times t is 40t. 1 times 20 is 20. We divide each side by 40. And now we will then get that t is equal to, let's write this up here, t is equal to 1/2. All right, so our answer for this, it depends on how I'm asking you. You could say it's equal to 1/2 hour. That will be fine. You can say t is equal to 0.5 hour, although I wouldn't really like this one. I would prefer for you to say a half hour. But if I ask you this, I might also say, tell me how long in minutes. So that means that this half hour is equal to 30 minutes. So it depends on how I'm asking you to answer this question. You might need to know how to convert those into minutes as well. And to do that, all you would do is take your time, this 1/2, and you would times it. Since we're talking about hours and wanting to go to minutes, and there's 60 minutes in an hour, you will just times 1/2 by 60, and that will give us how many minutes. All right, but for now, it just depends on how the question is worded and what they're asking for. But any of these will be acceptable for answers right now, and we'll go through in further detail about what I will be expecting for each particular question. All right, that is it for this video.